Multiplying polynomials, part 1. What we're going to do first is we're going to refresh our memory with a couple of these problems. It says distribute the following expressions. So distributing means you're going to multiply. And in this case, we're going to multiply a variable, also known as a monomial, times a binomial. Now the reason this is a binomial is there's two terms inside of the parentheses. Okay, so two terms means binomial. Here's the first term, here's the second term. Okay, so distribution means multiply, like I said. We're going to multiply this outside number times the first term. Now remember, there is a 1 in front of the variable. So what's happening here is we have 1 times 4, k times k. Okay, that's just this part. Okay, so 1 times 4, of course, we know that is 4. K times k, here you have to be careful. K times k is not just k. Okay, this here is something that we did a few weeks ago, properties of exponents. You have two bases that are the same, they're getting multiplied. Each base has a power of 1, so k times k is 2, k squared. You add the powers. Moving on to the next term, 1k times negative 7. So this is 1 times negative 7 times k. 1 times negative 7 is negative 7, so minus 7, times k, we'll just bring the k down. This is what we get after we multiply. Okay, so the next one, again, we have a monomial times two terms, which is a binomial, so I'm going to write it down. Monomial. So we have this outside term multiplying what's inside, and we're going to take care of this term times the first term from inside the parentheses. Okay, so this is saying 3 times 11 and m times m. So 3 times 11 we know is 33. M times m, properties of exponents. Same base, they're multiplying, so because of that you are allowed to add the exponents. So m times m is m squared. We move on to the next term, 3m times negative 2. Okay, so this is saying 3 times negative 2 times m. 3 times negative 2 is negative 6, and keep the m. Okay, that is what we get after simplifying, after multiplying, I should say. Okay, so what we're going to do next is we're going to multiply a binomial, so I'll write it down, times another binomial. Okay. Now there's several ways that you can do this, but we're going to focus on 3 methods, the most commonly used, the most easiest to understand in order to multiply polynomials. Okay. So the first method, it is the distributive property. We've used it, you've seen it. Okay, nothing different, except now we have 2 binomials. So in order to understand how we're going to use the distributive property, because it's a little different, not a lot, just a little, what we're going to do first is we're going to pretend that this term doesn't exist. So I'm going to erase it. Okay. So with that term gone, here we have a monomial times a binomial. So what we would do is, of course, we would distribute the x times x and x times negative 6. So I'm going to rewrite exactly what's going to happen. We're going to multiply x times x minus 6. Okay. Now, I'm not going to distribute it. What I'm going to do next is bring back the plus 2. Okay. Next, now I'm going to ignore this x. So ignoring that x, pretend it's not there. What we would do is just distribute the 2. So distributing the 2 would give us plus 2 x minus 6. Okay. So basically all what's happening is I kind of split this binomial in 2 parts, and I'm multiplying it to the second binomial. That's why I had to copy it twice. So I'm going to distribute x times x, x squared, x times negative 6, negative 6x. So I'm done with that. Moving on to the next part. Distribute the positive 2 times x, and that is a positive 2x. 2 times negative 6 gives us a negative 12. Okay, so we have distributed. What we're going to do now is, before you say, oh, okay, that's my final answer, pay close attention to the polynomial that we have and think, can I make this any smaller? Can I simplify? And the answer is yes. As you can see here, those two have something in common. They have the x. Okay, not this one. This one has an x squared, so that one has nothing to do with the other two terms that I highlighted. So this means combine them. So those two go together. Okay, I'm going to bring down the x squared because we're not doing anything to that. Negative 6x plus x, well, they have an x in common. Negative 6 plus 2 is just negative 4. Bring down the minus 12 as well. Now we can say, okay, this is our final answer. We have simplified, we have combined what we can, so that's it. Multiplying these two together, and this is the result that we get. Okay, let's try another example. Again, we're still using the first method, which is the distributive property, and what we're doing is we're going to split this binomial in 2 parts, and we're going to copy this binomial twice. Okay, so again, we're going to pretend this term doesn't exist. So with that out of the way, we have x times x plus 4. Okay, so let's bring back that minus 4, and let's pretend the first term doesn't exist. So here we have negative 4 times x plus 4. Okay, so I'm going to distribute this whole polynomial here, or whatever is happening. Here we have x times x. That gives us x squared. X times 4, that gives us a positive 4x. So moving on. Negative 4 times x, negative 4x. Negative 4 times a positive 4, that gives us a negative number. 4 times 4, 16. Okay. Again, before you stop and say, oh, that's it, that's my final answer, you have to check and see, are there any like terms? The answer is yes. Okay. We got to combine 4x and negative 4x. So I'm going to bring this x squared down because nothing's happening with that. You have 4x and you take away exactly 4x. What you're left with is just 0. Not 0x, just 0. So bring down the minus 16. Now, this problem looks a little weird because we have a 0. So rewrite it. We don't need that 0 to be there. So we write it, and that would be our simple answer, x squared minus 16. What this is saying is that our middle term, right here, those two got canceled out. So we don't have an x term. We have an x squared term. We're just missing the middle one, the x term. All right, moving on to another problem. Again, I'm going to split this up, these two, and I'm going to pretend that this minus 5 is not there. So here goes my problem. X times, okay, bring this back, and now I'm going to pretend that the first term doesn't exist. So now we have 5 times the second binomial. So we're going to distribute. We're ready to multiply these. X times 3x. Okay, there's a 1 in front of the x. So 1 times 3 is 3. X times x, x squared, add the powers. 1x times negative 2. So 1 times negative 2 is negative 2. Don't forget the x. Bring it here. Alright, moving on to the next here. Negative 5 times 3x. Negative 5 times positive 3 gives us a negative 15. Bring down the x. Negative 5 times negative 2. Negative times negative is positive. 5 times 2 is 10. So we check, okay, any like terms here and here. Put those two together, and we get negative 2 minus 15. Add the two numbers, keep the sign. So that is negative 17. Keep the x, and bring these two terms down. So that is 3x squared and plus 10. So our final answer is this trinomial that we have here. Now, there is a way for you to check if you're doing this correct, and that involves using the calculator. Okay, so you'll be learning some of that in class. Second method, the FOIL method. This is a very, very popular method, and you're probably wondering, well, what is FOIL? Okay, FOIL is the process in which we multiply these two binomials. Each of these letters represents something. Okay, so the F here stands for first, the O stands for outer, the I stands for inner, and the L stands for last. Okay, so we're going to multiply these two binomials using this specific order. Okay, so the F in FOIL stands for first. This means you're going to multiply the first term of the first binomial times the first term of the second binomial. Okay, so here we have F. So that is y times y. Now, you might want to be using arrows because it's very nice how it helps you organize your work. Okay. Next, we're going to use the outer, the O. This is this first term times the second term of the second polynomial. So the two outer ones, as you can see. Okay. So this is O. And we have y times 5. So I'll put that here. The I stands for the inner terms, the two terms that are closest to each other. They're in opposite parentheses, but they're closest to each other. Okay, so the outer, the inner term is this one and this one. Okay, so this is 7 times y, 7y. And finally, we have our last term, and that's exactly what it means. the last term of the first binomial times the last term of the second binomial. Okay, so that is 7 times 5. So I'm going to go ahead and multiply these two. Y times y is y squared. Y times 5 is a positive 5y. 7 times y is a positive 7y. 7 times 5 is a positive 35. Again, before you say, okay, that's it, do you have any like terms? Yes, we do. 5y plus 7y, okay? So we bring down the y squared. 5 plus 7 is 12 with a y, and we bring down the 35. This here would be our final answer. Okay. All right. Again, FOIL method. FOIL stands for first, outer, inner, last. So I'm going to copy this again, even though it's not necessary, but just so you understand where I'm getting these numbers from. Okay. So we start with F, and it is the first term times the first term. So here we have C times 2C. Then it's the first term times the last term of the second binomial. These are the outer terms. So we have C times a negative 9. Okay. Then we have I, the inner terms. This term times this inside term. So here we have negative 5 times 2c. Oh, I'm running out of space. And finally we have our last term, L. Negative 5 times negative 9. So I'm going to make it fit here. Negative 5 times the negative 9. Barely fit. Okay. So let's go ahead and write this out. This polynomial, c times 2c. This is the same thing as 1 times 2, because there's a 1 here. C times c is c squared. Okay. The next one, c times negative 9 is just negative 9 with the c right behind it. The next one, negative 5 times 2c. Negative 5 times 2 is negative 10. Bring down the c. And negative 5 times negative 9 is a positive number, and it is a positive 45. Okay. Combine our like terms, this term and this term, and we get a simplified answer that is 2c squared, that comes down, negative 9 minus 10, add the two numbers, keep the negative. So that gives us a negative 19c, and bring down the positive 45. This is what we get after we multiply the two binomials. Okay. All right, let's try another example. But this time, I'm not going to write down the F, the O, the I, the L. Okay. I'm just going to write here. F stands for the first. O stands for the outer. I is for inner. L is for last. Okay. So the first term times the first term. This is 2x times x. 2x squared. Okay. The first times the last. These are the outer terms. 2x times negative 2. 2 times negative 2 is negative 4. Keep the x. Okay. Then we have our inner terms, the two closest to each other. Positive 8 times x. Positive 8x. And then we have positive 8 times negative 2. Negative 16. Okay, so we have just done FOIL. Combine the two like terms, Negative 4 plus 8 is the same thing as 8 minus 4, which is just positive 4. Bring down the minus 16, and that's it. This here is our simplified answer. Okay. Let's try another one. Again, I'm not going to write down the steps for first, outer, inner, last. I'm just going to draw arrows. The first times the first. So this is 3 times 2, which is 6. X times x is x squared. The outer terms, the two that are as far away as to each other. So 3x plus 7. 3 times 7 is positive 21. Keep the x. Then we have the inner ones, negative 4 and 2. X. So that is a negative 8x. And our last, this last term times this last term. That is a negative 28. Okay. We combine the two like terms that we have. Okay. The 6x squared comes down, plus 13x, bring down the 28, the minus 28. And this is our final answer. Okay, so these are the two methods. On the next video, I will be showing you the third method.